All right, so we're going to continue learning about long division today. For this lesson, I think it's important to learn the technique of using some estimation to come up with the numbers that you're going to do for your division. It's going to help to get like a logical guess or a ballpark figure as far as what's going to help you out. So that's what the basis of this lesson will be. We're going to skip the warm up for today. In fact, we can go right to the notes on page 81. Now, as we go over this video, feel free to pause it, rewind it. Um, if I start rambling too much, you can fast forward a little bit. But if I do go too fast, you have the ability in YouTube just to kind of drag it back a little bit and find the spot where I left off. But let's get started. All right, so a toy company packs 504 robots into 21 boxes. Each box has the same number of robots. Show how you could estimate the number of robots in each box. So they're not asking us to solve it. They want us to get a general idea or a good guess for about how many are in there. So you may be tempted to divide 504 by 21, but we want an estimate. So in your books, and anything I write down, you guys can write down. So an estimate, that is like a rough guess. So you're guessing, but you want it to kind of make sense how you're doing it. So, for example, let's underline this number. We've got 504 robots. That's going to be our dividend. That's the amount that's being divided, and into 21 boxes, that's going to be our divisor. Again, I'm really trying to get opportunities to use these words as often as possible, so we can use that language to kind of understand the math better. The answer is going to be a quotient, but we aren't even close to that yet. But what we have to do is come up with some numbers that make sense. So 504 and 21, those don't feel like really easy numbers to work with. So we're going to change um, 504, we're going to change that to 500. And 21 is a fairly easy number to work with, but if I'm changing 504 to 500, why don't I change 21 to 20? So now we have two numbers that have zeros in them, and that's going to make it easier for us to do the work. Down below here, so we have about 500 robots divided by about 20 boxes, and that's going to be our answer there. So as we talked about before in a previous lesson, multiplication and division are called inverse operations, which mean they can undo each other and they kind of work well together. So we can change um, this division problem into a multiplication problem. So let's change this into 20 times something should give me 500. And what we can look at is this. So let's look at this 2, then underline the 50. So when we multiply by 2, we're doubling something. So let's think about what half of 50 is. We know half of 50 is 25. So let's go with 20 times 25 equals 500. And that means our answer, since this is an estimate, it doesn't have to be a perfect answer. Our answer is going to be this. There are about 25 robots in a box. Now, is it the exact answer? Well, we don't really know because we're not really looking for that. But the 25 here, that's supposed to be our quotient, supposed to be our answer for that. So there's about 25, but it's a heck of a lot easier to try to find what you can multiply times 20 to get 500 than what you multiply times 21 to get 504. So keep that in mind. All right, so there's a lot of the heavy work here. Let's turn the page. So for this, you can even use an area model to do this. Over here, let's label this as our area model. Um, so we could do 20 times something equals 500, but we know that that equaled 25. So compatible, but let's read what we have up above here. I'm getting a little ahead of myself. Underline this phrase here, compatible numbers. They're numbers close to the values of the actual dividend and divisor that allow you to multiply or divide using basic facts. Um, so the 500 and the 20, those are what we call compatible numbers. Your classwork today in iExcel will be all about finding compatible numbers. So this is super important for today's lesson and getting your iExcel done. So you want numbers that are close to the same value. So for 504, if I chose like 675 or 1000, that's not really compatible because those numbers are too big. For 21, if I'd picked 50 or 10, those are not compatible because their values aren't close. So right here, close to the values, that's what we mean by compatible. So just keep that in mind. Down below here, you can use inverse relationship to solve these. So again, that's kind of what we did on the first page. We could do it like that. But over here on the left are number of robots per box. Over on the right, their total number of robots. Over here would have been our divisor. And over here would have been our dividend. We don't have to worry about that for now, but you can make a table to kind of get an idea of the numbers right for that. So just a technique to keep in mind. All right, so let's look across at page 83 and let's put together some notes. Look at the first modelet, and that's the area model. Why are 520 good choices to use for compatible numbers? Why not round to the nearest 1,000 and use 1,020 as compatible numbers? And this is the reason why for the numbers you pick have to be fairly close to your originals. Is if the dividend and divisor are close, the quotient will too. What I mean by that is if you're compatible, if your dividend or your divisor, one of them's way off, your quotient or your educated guess or your rough estimate will be way off too. So be careful with that. 2, how can you find the quotient 500 divided by 20? That's pretty simple. We already solved that, so let's put it in there. 500 divided by 20 is 25. And it's going to be 25 robots. Number 3, look at the second modelet. That's one with a table. Why did you multiply 21 by multiples of 10? Could you multiply 21 by multiples of 5 instead of by multiples of 10? And here's the reason why we use a 10 instead of a 5. Multiples, aside from the fact they're easier, this is why they're easier. Multiples of 10 only deal with one non-zero digit. Okay. Look at the table. Between which two numbers is a good estimate for the number of robots packed in each box? That's between 20, which the dividend ended up being 420, and 30, 630. And what do the methods of estimating quotients in the model have in common? And this is a kind of a general answer, but they both use, I'm putting this in quotes because it's kind of an opinion, but I think it's using easier numbers. That's what they have in common. Making compatible, easier numbers makes your division way, way, way easier. Okay, let's turn the page. We got 3 problems I'd like us just to do to get some practice in. All right, so we skipped 6. Just forgot to mention it. 7, estimate the quotient 342 divided by 38. Split up your workspace into 2 spots. I just want to show you something. So 342 and 38. So we have to find compatible numbers. And above here, let's use that, compatible numbers. If you're having trouble remembering what compatible means, it means if you're compatible with another person, it means you get along really well. If Yeah, so just think of it like that. If you're compatible, it means you get along, you work well together. But for this one is a little tricky if you don't have a lot of practice in it yet. So I'm gonna 342. I thought about 440 for these 2 numbers, but I took another look at it and I thought, well, wait, if our goal is to make compatible numbers be close to what the original numbers are, 350 and 35 would make a lot more sense. So over here, 350 times something, so would give me 35. That's something to consider for that one. Or 350, excuse me, 350 divided by 35. That will equal 10. 10 for that one. Sorry for the mistake. So our solution is close to 10. Let's look at the next one. All right, it says estimate the quotient 1,103 divided by 23 and show your work. All right, so let's see what we have here for this one. All right, so I want you to draw a line down here, and I want us to split this up into 5 sections. So I'll give you 1, 2, 3, 4 lines. So we're just making a very simple table here. So let's put 10 up here, 20 here, 30 here, 40, and then 50. Okay. So for these numbers, we're all multiplying by 23. So 10 times 23 is 230. 2 times 23 is 46. We bring down our 0. 3 times 23 is 69. Bring down a 0. 4 times 23 is 92. Bring down a 0. And 5 times 23 is 115. Bring down a 0. So for this one, we can easily see that since we want this number is going to rest between a couple of these, know our answer will be between 40 and 50. So when it says for the solution, your answer is between 40 and 50. All right. One more and we're done. All right. So Camille arranged 238 chairs into equal rows of 14 chairs. Which of the following is the best estimate for the number of rows she made? So let's take our original numbers, and this is where we decide what our compatible numbers are going to be. So these are not easy numbers to work with, so let's make them easier yet compatible. Let's go with 200 for this one, and let's change 14 to 10. And down below here, we can say 200 divided by 10. That can give us an answer of 20. So for our choices here, which of the following is the best estimate for the number of rows she made? Since this is our answer we got from our compatible numbers, we know our answer will be B. Now for your classwork, so we haven't done IXL in a few lessons, so we're going to do it today. Now this one's D9. It's called Estimate Quotients, two-digit divisors. We've been using one-digit divisors this week, but towards either Thursday or Friday, we'll start using two-digit, just because that's the goal of to get us there. We got a little bit of review, got a little bit of warm-up, but two-digit divisors is the end goal for this unit. But for today, this IXL, it's just going to be estimating, and you only have to go to 70%. And once that bronze medal pops, you can be done. Now, I'm not there to give away house tickets for kids to go to 100, so you can just for fun. But again, I'm not there to hand out house tickets for today. So good luck with everything. I'll be back on Thursday if you have any questions.